Do a quick video on reading the reverse torque values that are generated by a joint when you put the Dexter into the keep position mode. This is useful because you'll want to, if your end effector has contact with a surface that where it's appropriate to have some contact but not too much or not too little, you can use these values to kind of calibrate how much pressure the end effector should have. In my case, because I'm cutting people's hair, my end effector is a trimmer, and that trimmer needs to have contact with the skin, not too much so that I don't hurt the person, but not too little so that no hair is cut. So it's pretty cool that these values are exposed to us. So let's take a quick look at our code. What I'm doing here is I'm putting the arm in the keep position mode, and then I'm reading these PID delta values, and these don't have a unit, but they're enough to kind of tell when there's external force, or really any force being applied. You probably want to normalize them because there's going to be gravities in play. So there's force already being applied. In fact, if I run the code as is right now, you'll see these values next to each of the joints, and some of them have pretty significant values beyond 0, especially joints 4 and 5, which I'm guessing is due to gravity, because my end effector also has a servo built in. So let's take a look at joint 1 right now. It's 0.104. What I'm going to do is I'm going to apply some counterclockwise force to my first joint, which is right here. So I'm going to take my hand. I'm going to try to twist this way in the counterclockwise direction. And when I do that, we can hear that the servo is resisting that. The winding noise kicks up a little bit. And then, so before value is 0.104, if we reevaluate it, we see 0.77 now. So we see that the value went up. Again, this is the pressure that's coming, the reverse torque is being detected, and it's kind of coming out in that value. So if I let go and I rerun my code, it should probably jump back down to 0.1. So that's with when my hand isn't there. What happens if I try to twist in the clockwise direction? So I'm going to twist like this. If we try to do that this way, again, we hear the servo winding. It's trying to resist, and it's successfully resisting. And then if I rerun the code, I'm going to see a negative value. And we do. We see negative 0.37. I'm going to turn even a little harder. Expect that value to go up a little bit. And we see it negative 0.5, so it went up. So this is a cool way to kind of read those resistive forces and hopefully take action on them.